Good morning, class. How's your day? Oh, good. But first, let us check attendance. Oh, it seems that no one's absent. So good. Let's give yourself a round of applause. So before we start our class, may Miss Song please lead the prayer. Amen. So as a recap, what was our topic last time? May? Correct. Our topic last time is about work. So what is work? So correct. Work is force applied times distance. Now, let us proceed to our next topic. Our next topic will be a secret. So before we proceed to our next topic, I have some video clips here. I have here someone I want to introduce to the class. So first, do you know who Blaze is? Okay, so since you don't know who Blaze is, let us watch this video. Okay, class. So upon the video you just watched, can you guess what our next topic will be? Okay, so our next topic is about the Newton's 3 laws of motion. So before that, I have someone here I want to introduce. Sir Isaac Newton was an English mathematician, physicist, astronomer, theologian, and author who is widely recognized as one of the most influential scientists of all time, and as a key figure in the scientific revolution. So, Sir Isaac Newton is a scientist who is the author of the 3 laws of motion. That is why 3 laws of motion is named after him. So, Newton's 3 laws of motion. Number 1 is the law of inertia. Number 2 is the law of acceleration. And number 3, the law of action reaction. So first, let us tackle the law of inertia. The law of inertia, also called Newton's first law, postulates in physics that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by a force. So the law of inertia states that an object will remain at rest or in uniform motion unless acted upon by an unbalanced force. So one example of this is this one. This player is playing soccer or football. So this ball is the object and the unbalanced force is this player. So an object will remain at rest or in uniform motion unless acted upon by an unbalanced force. So the unbalanced force in this picture is this player. So, ending a ball, hindi na siya magiho if hindi siya pag-isipaon sa player. All horizontal motion required a direct cause, said Galileo Galilei, an Italian astronomer, physicist, and engineer from Pisa. Galileo has been called the father of observational astronomy. So, this is an example of the law of inertia. Watch closely at this one. I know we both experienced this. Upon riding a bus, you are at rest, sitting in your seats. And when the driver hits the brake, you are suddenly pushed forward, and that is the unbalanced force. Okay, so this one. Can you guess which one has greater inertia? Giselle. Correct. So, the one that has greater inertia is the elephant because it has greater mass than this boy. So, the second law of motion is the law of acceleration. Law of acceleration, also called Newton's second law, states that the acceleration of an object depends upon its mass and the magnitude of the force applied to it. So in this picture, the other cart contains nothing, while the other cart is loaded. Which do you think have greater acceleration? May? Correct, the one that is empty. So the empty cart has much acceleration because it has lesser mass. Next one. So the law of acceleration is the state of moving on. So in this picture, what can you infer? Which one has greater acceleration? This boy being pulled by 2 persons or this boy being pulled by 1 person? Giselle? Correct. So the one pulled by 2 persons has greater acceleration because it has greater force applied to it. And since I said that acceleration is the state of moving on, I have here a meme about acceleration. Mas madaling pag-aralan ang gravity kaysa acceleration kasi mas madaling ma-fall kaysa mag-move on. So what can you say about this meme? May, Miss Song? Do you have the same experiences?
Yes, ma'am.
Correct! You are in the state of moving on. Correct. So, let's proceed to the third law of motion or the law of action-reaction. The law of action-reaction, also called as Newton's third law of motion, states that for every action, there is an equal and opposite reaction. So in this picture, this man is rowing the boat backwards, but the boat is moving forwards. So there is an opposite reaction applied. And this one, this skater boy pushes the skate backward, but his direction is moving forward. Okay, so before we end this topic, let us watch again another video. Okay, so guys, what can you say about the video? Very good. Now, let's get a 1/4 sheet of pad paper and let's do this activity. Okay, time's up. Pass your papers. Okay, class, for your assignment, think of anything that happens usually with your daily life that possesses the 3 laws of motion and discuss in the class about how the laws are applied. Okay, class, so that's it. Thank you and class dismissed.